Thanks for the great introduction. Thanks for having me here. Our friends at Weights and Biases are always super helpful for us and also invites us to these things. This is my second time talking for them. So again, thanks for the opportunity. As said, I work for Rad AI. This is almost my 5th year in the company. I'm the first software engineer hire. I've been through many fundraisings, years of growth, and I've been part of the model team in the last 2 years. And honestly, before that, we weren't crowded enough to have that type of separation. So I was lucky to work with different researchers over the years that contribute to many machine learning models we have that is currently serving radiologists. So yeah, that's a quick introduction about myself. From here, I have 3 overall objectives today. 2 of those, which I'm pretty sure I can get done. The third one is to show you a small pipeline, at least the main modules, components that you can use to utilize weights and bias automations. Maybe I can go through that too. When I tried this at home, it took me a little longer than I wanted, but maybe we'll go fast. For your questions, let's keep them until the end, so I have some extra time to go through all the material I want. So that's about it. Let's start. I'll start with introducing Rad AI in more detail. Maybe give you some history and what we do and how we are changing how radiology is being done in the United States for the last several years. So here's a nice visual that somewhat accurately represents what we do. It's a little bit more cartoonish, but that's how I like to imagine Rad AI helping radiologists in real life, let's say. So empowering radiologists with AI, and let's get started. Quick background, Rad AI was founded in 2018 with investment led by Google's AI fund, Gradient Ventures. They focus on these type of seed-stage startups in deep learning space. Well, back then it was called more deep learning. These days it's more like AI and generative AI, I suppose, primarily. We have 3 products so far. Rad AI Omni, which has been our flagship breakthrough product. We have 2 more newer products that are also gaining a lot of traction very fast, Rad AI Continuity and Rad AI Reporting. So today I'm mostly going to focus on Rad AI Omni and what it does and how it changed, at least slightly changed how radiology is done, and it just made many radiologists a lot more efficient and probably make their lives easier by reducing the repetitive work that they end up doing every day when they are at work. So from there, a new radiology workflow. So in here, I'll be talking about our first product, Omni, which I've been every part of its development over years. So I think to best explain it, I need to give you some little bit of context or how radiology works. So let's take a step back from the diagram. When let's say you need to get a radiology study. Think about an X-ray, a CT, an MRI. Bunch of reasons from breaking your arm to having something a little bit more serious. So we all somehow at some point in our lives end up in a hospital or had to get a scan of some sort. So the way this works is you would end up in a location where you can get these studies done by a technologist. You get your scans taken. Then that information, one way or another, this varies across hospitals or states, or general the practice, but in some way, that study needs to end up at a radiologist's desk. So the desk in MAM, this is more like a traditional way of saying it, but modern days it's a workstation. There's a queue of reports, studies that you need to go through with some velocity through the day to analyze as many studies as they can. So that's the radiology flow. You go in, someone takes your scan, and that information, those images ends up in a radiologist workstation, which is usually not the same location that you got your scan at, for many reasons. And that's usually what happens. So radiologist sees the study, looks through the images, puts in the findings, then they would put in the section that is called impressions in the radiology jargon, which essentially, from my perspective, not really different than a conclusion section for an essay or an academic paper, where you synthesize the previous information. In this case, would be the findings or maybe the indications or some combination of those. You also list down the implications of the previous information, which might not be part of the part of the existing information, but something you can derive from looking at that information. And some bells and whistles around that. So that second part, it used to be the case that second part would be written by a radiologist until roughly the year 2020 and 21. So since then, we built this product where the radiologist would put in the preliminary findings, then we would receive that information through our APIs. We have a machine learning model, well, more precisely, series of, let's say, inference services that take place in generating that final impressions section of the report. So another simple way of thinking about this is, instead of writing 2 blocks in a report, radiologists these days usually write only 1 block, and we would generate the template for the second block. Well, radiologist reviews and approves the report, the part that we generated. They make sure it's accurate, it has high quality, and they add any insights if necessary. But we make sure we produce a draft that is good enough by itself and workable with as is, and that's usually the case. So I have a small video here that would demonstrate what we're doing better. It's a little bit hard to follow if you're not familiar with the pieces of software you see in the screen. So maybe I'll pause and maybe come back and forth, but this is just trying to show you what I just explained. So radiologist, creating the first section of the report, and our software completing the second part. But what's happening is we have a radiology report. This is a specialized software for radiology, writing radiology reports. And our application is actually pretty invisible, which is something we really like. It's sitting on this in this little box here, and it's watching what's going on in your editor. And from there, when it's time, you will see that the impressions, the conclusion section for the report will be injected magically in a kind of a sudden manner. Following the cursor here, okay, so it's already in here too. So that's one example. I'm not sure if it was super visible. Maybe let's try looking at it one more time. This is the shortest example I found, but you can see here the impression section is empty, and all the information is right above. And you see the user scrolled up, and the impression is right there. Again, this used to be, this information here, this impression section, this 6 items would be created by radiologists previously, and now we do it. So we work with 10 out of the 9 largest radiology groups in the country. We have more than, I guess, around 150 customers now. So if you received a scan recently, it's highly likely that you've gone through this, your study has gone through this process. So just to summarize, last year we have generated over 15 million radiology reports. with around 1.0 seconds median latency and as I said, we have many partnerships, and our products are gaining a lot more traction. If you know a radiologist, they probably either worked with Rad AI or heard about Rad AI in the last couple of years. Okay, so this is the part where I wanted to sort of catch you up with what we're doing. And I think I'll take a brief pause here, even though I said let's keep the questions a little later. If you have any questions, this is about time. If something is not clear, let's make sure it's clear, because from now on, we'll go get a little deeper in how this is done and how weights and bias is helping us doing it. Okay, another image that I really like, I got really better at this once the ChatGPT is out. So how we do it? So I am responsible for Rad AI's online inference systems. So brief summary or definition is, when I say online inference, the way I think about it is there's usually someone on the other side waiting for that inference, right? If you think about the flow I explained here, and if you think about that radiologist needs to do this many times throughout the day, when they create those findings, they would like to receive the impressions as fast as possible. So this requirement has always been very paramount in our trade-offs, in our decision making, and it really altered the way we think about our system, and it's also slightly different than the current chatbots you interact with, which take a little bit more time, and you are usually fine with that. Partly you're not in a hurry in this, you're not doing this repetitive work that you need to go through some volume every day. Partly, I guess, the illusion of streaming makes things look a little faster and all that. So from here, let's go a little bit deeper into technicals and the Rad AI's main challenges in making this happen, and I'm going to tie to weights and biases from here. So the first and most significant part of our server side is we are using machine learning and AI not just for the main task that we are doing. So this would be the product I showed you. We also use it in many different areas. We use it for monitoring our systems. We use it for evaluating our results. We use it for customizing our results for the doctor. Our customer support team uses services that are backed by AI, and this so on and so forth. Since from the early days, our team was very much skewed towards more like scientists and researchers. So when we had a problem, the usual approach would be, can we make a model for it? Which ended up being very powerful, for we solved many problems that has never been tackled before. We can do many things that you would have a very hard time implementing with a rule-based approach. So it's all great and wonderful. So the problem here is, once you have this type of system where different machine learning models are sort of central to business processes and they're that integral, right? What happens is you end up in this sort of model hell, in the sense there would be many models that different researchers are leading that are serving some critical business process, and these models, they just need to be updated frequently, right? They need to be operating with the quality that our customers expect from us. Or a different way to do is just, you want to put your researchers in a position to build more models, change them more frequently, ship more models. So this has been a challenge that we've been dealing with since the early days. These machine learning models come with very specific resource requirements to run them. They all need this data to be pulled in, whatever is going to run that model. So they have these sort of peculiar requirements. Puts you in a position to come up with different solutions, let's say. So this slide is more like, I'm going to talk about our general approach. So when we sit down and we thought about, okay, what are the properties we desire from a server-side system so that we can do this? we can build this product and keep iterating as frequently as we want, and create ourselves this space in the field. The first thing that is obvious is, and this is probably shared with any company, it's frequent deployment, and it's getting quick feedback. So this by itself requires a streamlined approach, as you want to update the existing model, collect your training data as fast as possible. Even though it doesn't make sense at all times, you want to be in a position to do that when it matters. The other approach, the other critical point, property we desire from our system is obviously the researcher productivity. Usually, when a model is going to be part of a production system and it's going to be serving customers, there will be a synchronization step with researchers and machine learning operations professionals, let's say, or the engineers on the team that are more closer to software side. And we find that synchronization has a potential to slow researchers down. So we wanted to get around that too. And the last part is, as I mentioned, our systems are online, which means that they usually need to be up 7/24, and they need to maintain an operational quality throughout that time period that they're up. This requirement, if you think about it, we are also integrated in the healthcare workflow, radiologist workflow, and there's also, I think, sort of another element of it that makes this operational quality important as you're part of the healthcare flow. And luckily, there only has been one brief outage in the recent years. Even then, when that happens, radiologists slow down. So just overall, our capacity to read radiology reports in the country goes down suddenly, and very undesirable problem. Aside from it being a simple business problem, I would say. So again, frequent deployment, researcher productivity, scalability, operational quality. These are properties that we can't really give up. If we give these up, our product wouldn't work. So these were the properties that we were seeking for. Now, going back to weights and biases. So weights and biases, I think if you have been using the product for a while, it used to be more like a research-oriented, training-oriented product where you would follow your experiments. You can see your loss functions converging. That's a great thing to see, and it's how we adopted weights and biases. I kind of remember the day someone reached out to me, hey, can you add API keys to this instance, something like that. So that's how it started. I think this was late 2021, 2020, early 21. That's how I remember it. Again, I think this part, the model registry, you're all a lot more familiar than what I'm going to talk about. This is where when you train a model, you just log some intermediate results. We usually metadata, how long things take, what is your loss, or things like that. So we have been using model registry, at least 3-4 years, and it's been around for a long time. And it was I think it still is it's everyone's favorite tool, especially for researchers and deep learning, experts. But what I'm mostly interested in is the weights and bias automations. So 2 slides ago, I was talking about the properties that we're looking for in a system. And to make some of those happen, last year around these times, I was in a search of like a tool or like a sort of a software architecture to address some of the goals to achieve those properties that I mentioned. So let's maybe go over some of them really quick. So one desire I had was to implement an infrastructure where these models are changed in an event-driven manner. So as I mentioned, there was a lot of synchronization required between researchers and software developers, more like software engineers in the team to deploy these models. And that involves a lot of repetition and a lot of human labor. This repetition can come from just writing the same code or mostly the same code over and over because it's not centralized and it's not being reused properly, or it's just human labor. People talking to each other. Hey, I have this model. Oh, did you really have that model? When is it going out? It's going out next week. Oh, I didn't know. Well, it was on the schedule. Some these type of discussions that we want to eliminate as soon as possible. The other was automating the change proposals, where when it comes to changing infrastructure with a new model it's not really obvious who's supposed to do it or who's supposed to own it. Ideally, these new models are made by researchers. So if they can propose the required changes to your infrastructure somehow, even though they don't know how exactly it would work or what needs to be proposed, as long as they can trigger it, we figured out that we can make it happen. So the third one is, again, a very simple property. I'm pretty much every server-side engineer would like to see a normalization, like a process normalization. But we needed this to just, make the product work. We needed some normalized, consistent processes across models. And those processes allowed us to sort of reduce the process variation across models and put us in a position to support all those research bandwidth and deploy all these models in a frequent manner and deliver improvements by responding to customer feedback as they interact with our models. So this is how we use automations. This is, now I'm gonna go deeper into the actual steps where we use automations and how they help us. I'll also talk about a broader, sort of a broader continuous deployment workflow maybe. So this image just completely lacks rigor and it kind of looks silly, but here my defense for it. So whenever I think about a continuous deployment pipeline, easily when you implement these, they get increasingly complex. There's many bells and whistles, different components talking to each other. So I usually start with this type of approach where I think, okay, what needs to happen in a machine learning deployment workflow? So this is how I think about it. So we need to train the model, we need to upload the model somewhere, and then that model needs to get registered. It needs to be somehow staged for deployment. Then it needs to get approved by machine learning operations engineers or software engineers on the team that are responsible for this. Then it needs to be run. So this is how I think about it, and this is very simple, as I said, and it kind of looks funny. But the next slide will be more satisfactory to technically savvy. So this is a very much stripped down version of a pipeline we use internally actually. I took out some bells and whistles that wouldn't matter overall in the outcomes. As you can see on the left hand side, we have the standard process of model training. I'm not going to go into that in this talk. It very much depends on your own company, your own use case, how you go about it. You can use a distributed training cluster on a cloud. You can just use a single instance, get somewhere. That's not part of my talk. But in the end, one way or another, once you have a model, your model will be in the form of some data, some artifacts. These can be weights, some configuration files, things like that. I'm sure the Hugging Face models that you see are a good example of this. There's a normalized model export. So this step, where this step gets relevant in deployment is the bottom part. Once the models the artifacts are uploaded, they are linked to weights of biases model registry. So there will be an artifact record created in weights and biases, and that artifact record will have a pointer to this S3 location, so it can be picked up. From there, this is purely built around weights and bias automations, and I think the most critical step here is the first step. Once the model is registered to weights and biases, the artifacts are on S3. The next step is, if you read through the automations documentation, is adding an alias to an artifact. When you add that alias on an artifact that you just registered, weights and biases triggers a webhook that makes a post request to trigger a GitHub Actions workflow. And then that GitHub Actions workflow automatically looks at what is in the current infrastructure, what will be the new state of the infrastructure after the change proposed. Let's say if we were to deploy this newer model replacing an older model, then it will open a pull request for you. So the people responsible for the platform people, the software engineers responsible for running off that model can review and approve. So I think two very interesting points about this that, the first one was, it took me a while to get used to that idea, is just automated pull requests. Normally, you're more used to developers opening pull requests and writing code. So this utilizes templates to create Terraform modules and open pull requests against the main branch where the infrastructure is synced with. We use Terraform Cloud to orchestrate these infrastructure changes and apply these infrastructure changes. Usually this works in a way that when there's a pull request open in your repository that you declare your infrastructure, Terraform Cloud or Atlantis or many continuous deployment integration software, watches these events in your repository, then can create these plans or apply the infrastructure changes. So then this pipeline ends up getting an approval for that automated pull request by an MLOps member that has hopefully some familiarity with your infrastructure and can approve those changes to your infrastructure, which in the end, these days we use SageMaker inference endpoints, but we would end up either replacing an existing endpoint or spin up a new SageMaker inference endpoint. So again, as I say, two major points here. The first one is the fact that the pull request is written by a machine, not usually something you do. And the second one is there is no programming involved. There is no developer communication involved. All you need to do is add an alias to an artifact, and then the staff responsible for the infrastructure reviews the pull request that this alias triggers. Well, this GitHub Actions opens, let's say. So let's see. I think I'm right at time right now. Yeah, it took over a little late though. But anyways, so the next would be to go over the implementation. I'm not sure. Can I do like 5 minutes? 3 minutes? Okay, 2-3 minutes. So I'll make sure to share this repository. I actually have it with me here. That has the required tooling for you to make a simple example of what I explained here. I have the repository has a script that you can log an artifact and link it to a model. There is a GitHub action workflow that handles these weights and bias automations events that comes after when you add an alias. There is a CLI for GitHub Actions to use. So this would be a Python program that uses Jinja templates to generate these Terraform modules, and some operations to create that pull request, committing the change, pushing that change, opening a PA. All these are programmatic automated. And the last one would be the actual Terraform module where you announce your infrastructure. So this would be the actual concrete infrastructure components, say in your cloud environment. Let's say AWS. This can be an AWS SageMaker endpoint or an S3 bucket or whatever else. And I am out of time. Okay. I wanna highlight this slide. This is the most important slide. Anyway, so we are actively hiring. If you are interested in what we are doing, if you're interested in improving healthcare in the United States, if you're interested in helping radiologists, if you're interested in just machine learning and working with us, find us, scan the link, find us after the talk. We'll be here. You'll be surprised there's actually four more people from Rad AI sitting in the back. Any would work. All of them are friendly most of the times. Please do that. And if you're interested in seeing the implementation and the pieces, I'll work with the weights and biases team to make this public. Right now, it's hooked up to our company's the system, so maybe not the best idea to make it public right away. I can work on that with them because I'm out of time. But at least I was able to deliver the slides that I wanted to. Hopefully, I introduce you guys to Rad AI and you have a better idea what we are doing. Hopefully, you got a little bit interested and thinking about applying and talking to us.